curating from the set of questions that came up over your talks. I think there's one that also came up this morning, but I thought is very timely, so worth asking. Again, from this group. David Goodman asked this. He said, given the pandemic, it seems a little surprising that current VR collaboration tools aren't seeing more use. Where do you think we are most lacking?
I could take that.
Yeah, sure.
Although I'm interested to hear what the others have to say. I think that every tool is good for something. Different tools are good for different things. I mean, if I want to use I love Illustrator, but if I want to make a 3D model, I won't use Illustrator. It's simply the wrong tool. So, so I think that VR has not fundamentally focused in a broad way on the sorts of social connectedness problems that, for all of its faults, something like Zoom actually has been used for. At NYU, you know, we're teaching classes on Zoom because it was actually designed for scaled up face-to-face meeting. And of course, there are a lot of problems with Zoom. Like, who am I looking at right now? Actually, I'm just looking at a camera. So, so we need to solve those problems. So I think that we're just now entering a time when, because of enforced social distancing, the right questions are starting to be asked that VR and various kinds of things related to VR will start to address. I think a lot of the work at places, you know, like what Mike showed and other places, are really right on target for starting to ask those questions. But until there's a market, things don't get into the world. And so I think this is really, to put it crassly, we have a need for it. And so therefore a market is now showing up.
Well, I think Ken had good points. I would say there are two things. One is there just hasn't been enough emphasis on it. I mean, I think you will see things now because it's obviously useful. But the other thing is, this is what I talked about, where I said that it's not just a software problem. And that's something that people still have a hard time wrapping their heads around. But adding capabilities to it that make it, you know, the ability to have avatars that really give you social presence, the ability to have environments that, you know, feel real and mix with the real world, you know, ability to use your hands, all these are important. Right now, you want to write on a virtual whiteboard. How do you do it, right? And I mean, that's the most basic of all things. So there's a whole bunch of stuff that has to come together, but there's also nothing that says this can't happen. And so I fully expect that it will happen.
I don't know, I'm not obviously an expert in AR or VR, but it does feel a little bit like, you know, in the current context, you know, we are at Zoom. On the other hand, you know, there is all this great work that happens in the various labs, which is a little bit maximal in some ways. You could look at it that way, as being kind of, you know, very, very, in some sense, kind of, you know, 10 years ahead or something. So I guess maybe something we need to kind of come at peace with is that maybe we need some sort of solution which may not be as immersive as what we are working on long term, but it's still better than Zoom, right? I mean, the question is, what would that be? What would be something that would sort of, you know, make us have a better meeting in 1 year's time, right? Something like that, I guess. I don't have necessarily good ideas of what would that be, but I think, you know, if you close the time horizon to 1 year, you know, what would we be able to come up with? What's realistic?
Yes, that's actually a very interesting point. Something that was interesting in Ken's talk is actually all the interaction he has been showing were happening in an alternate world with like more cartoonish type characters, right? So really, how much do you think, or do we think, photorealism is needed for all these experiences in VR, especially for communication and work collaboration?
So I have an answer to that, which is, I don't think there is one answer, in the sense that I think human beings have a very, very high tolerance for different sorts of avatars depending upon their application. When you read a novel, you read Pride and Prejudice, the avatar of Lizzie Bennet is just some scribbles on a page. When you talk to someone on a telephone, their avatar is an invisible person. And, you know, 1870, when people started talking on the phone, everyone didn't freak out because they were talking to ghosts. They're just like, no, I'm talking to only your voice, and I get what's going on. So there will be situations where you want to look at a literal person. We have a place in our culture for movies. We have a place in our culture for cartoons. Everybody knows that the by far the best Spider-Man movie was Enter the Spider-Verse, Turn on the Dark, and that was animated, and it blew away all the other. This is my opinion. It subjectively was much better than all of the other movies in the Marvel universe. So it's not about what the representation is. It's about, I'm using this tool for this purpose, and everybody agrees that this has the affordances I need for what I'm using it for. That's really what we should be asking, not did I achieve this? Because if you try to, you know, the stuff that Mike was showing was awesome, but if you try to bring it out too soon before it's ready, you just hit the uncanny valley, and everyone's like, what the hell is this? My friend looks like they have neurological damage. So you need to respect that while we're developing this, as Cristian said, we should be using that, because every tool we develop, we're learning from.
I mean, I think also there's different types of realism, right? So, you know, you could be perfectly happy with a cartoon-like character, but maybe the motion needs to be accurate. It needs to be very, very important. And you're probably less likely to hit the uncanny valley. So, for example, in the case of you know, animation or whatever, you may want to have very realistic motion, but a cartoon character would be better in some circumstances. Yeah.
There's a whole new language that has to be figured out here. It doesn't exist today. And so all these things are definitely true. And you know how we'll find out? We'll run 1 million experiments, and some things will work and some won't. And the great part is we can now start running the experiments. But again, you can't just run the experiment by writing software. And that is where it gets tricky, because you do need sensors to enable this. And it's one thing to do that in a lab. It's another thing to do it in a consumer part. And that, I think, will be very interesting over the next decade.
Maybe I can just say something about the previous question on this one as well. Is, you know, one thing I've noticed being in academia, that there's a very long tail in terms of technology uptake, right? So, you know, like those of us who are familiar with VR and AR or whatever, and Zoom, you know, like it hasn't been that much of a big deal, but it's been a huge learning curve for, you know, say people in the humanities, people who, you know, in the administration or whatever, who, you know, like finally we're getting people to use Blackboard. That's the online teaching tool. You know, like people wouldn't even put their notes up on Blackboard. They were afraid of it. And now they're using Teams, they're using Zoom, you know, they're using Blackboard or whatever. So I think, you know, it's the tail is the biggest part of for technology uptake, and that'll take a while, I think, for people to take that, even if the front runners do it.
Yeah, I like also what Ken was saying on the, you know, we need to transition slowly from avatars maybe to photorealism, and there's maybe application where avatars are more likable than photorealistic avatars. And more we go to a photorealism, more generalization of vision and ML model is important. And there were a few questions in the chat about, do we believe that ML and vision algorithm that we are developing will be able to generalize to work for more than 95% of the population, for example? And so will we solve that with some calibration, personalized calibration for our own devices, or are we going to solve this, and or are we evaluating this in general? And I think the question was in particular for hand tracking and eye tracking for Michael. She was asking you know, or do we know that this eye tracking and hand tracking algorithm generalizes, and did we do good studies for that?
So hand tracking, yes, I would say it does generalize. I mean, I think there's enough data now on that. Eye tracking is super hard. So that's totally unproven, in my opinion. Nobody has ever shipped consumer eye tracking, and there are a lot of challenges there. So I guess I would view the two as different. I mean, hand tracking has gotten to the point. The other thing to ask, of course, is how costly failure is in a tracking algorithm, right? If hand tracking fails, if you're operating virtually the controls for a nuclear reactor, maybe that's bad. But in general, if it's your avatar, if you're pushing buttons on an interface, it's a very soft failure. Eye tracking, it depends on what you're doing. If it's avatar's eyes, not a big deal. If it's pupil steering for a 2 millimeter beam, you know, you're blind all of a sudden because it's black. So, you know, it really is a question of what kind of robustness and reliability is needed. And I will say that it is a huge challenge to get to something that is effectively 100% reliable and robust across the whole population with the remarkable variation in morphology and eyes. Like, I've seen people with eyes that look like cat's eyes. I've seen people with eyes that have like extra circles in the iris of blockage, right? I mean, that is a tough one.
I agree with what Mike says. But also, there is this interesting data point, which is almost everybody that I ever encounter, I know where they're looking. So there is a solution in what evolution has put into our brains, which doesn't mean that we're going to get to it soon with our computer tools. So we know that the information is there, but it might be there at a semantic level that's actually quite difficult for us to reach with our current state of computer technology.
That one's interesting, Ken, because I agree with you, and yet it is what I would call the heart of the computer vision problem. So I did graphics for most of my career. Graphics, you can actually model to the real world. If you had enough compute, you would just model all the photons and all their interactions, and you could do it and it would be right. But there is no real world example of looking at something and knowing the exact angle to it and the exact distance. And similarly with eyes, you certainly know if someone's looking at you or not. You can tell if they're looking near or far. It's not quite the same as saying you know to within half a degree where they're looking. And
I know they're looking at, if they say, are you going to eat that? They know if they're looking at the eggs on my plate or the toast. You know, I mean, we generally know where people are looking because it's part of survival. But certainly not to this fine cursor level. We combine it with language semantics, and then we use deictic words like this and that, and they work because we have a good enough understanding of where people are looking.
Now this brings us to a super interesting point. I'm glad you said that, because the super interesting point is part of the reason we know it is because we semantically interpret the scene, right? I mean, you know that they're not looking at like one of the pieces of the egg or the plate, you know, edge of the plate, because you don't eat plates. And that's where bringing in all this contextual information, which is entirely a computer vision problem, right? That's where it really matters, because, you know, you can say you know where you're looking. What does that mean? Okay, once you can start interpreting the scene, it's really important.
And that's why I said there are semantic levels here that are still challenging for us. A complete agreement, yeah.
So this brings another interesting question, I guess, because you said the forward process, or the graphics forward process, we can do that very well, but the inverse process is hard. And so we talked a little bit about synthetic data, and let's say we can generate photorealistic synthetic data. But for what I understand for what you were saying, is not only photorealism that matters, also the context of the scene and all that. And that's much more complicated to model. So do you think synthetic data is actually the key to solve some of these ML problems? Or is there more to like photorealism, like what you said, modeling correctly the scene and interaction with the scene, which are much more complex to do, I think?
I think synthetic data is a significant part of the solution, absolutely. I also want to make an important distinction, because if you're talking about AR, VR, and you're putting virtual things in the world, that's one aspect of doing computer vision. But if you're talking about interpreting the world so that you have an assistant that actually can give you contextual information, that's another one. And there are really two different aspects of it. And that second one, that's the one that I think goes on forever and changes the world, right? Because that's the one where things become ever more personalized, contextualized, and AI becomes more capable of helping you.
I have a few observations regarding when, I guess, a little bit going back to the observation that, we know what the others are looking at. I guess, as with many other things, we believe we know, but for the most part, we are right. But I guess, obviously, we shouldn't forget that we fixate on average 3 locations per second. We may look at the edge of the plate as much as we look at what's on the plate, and probably on average, we look more there than on the edge, but we still look on the edge. And I guess, I mean, that may not be important if we actually want to, take the gaze in aggregate in some sense. But it may be important if you want to be veridical about really understanding the details. My other observation regarding data, it's also that I think from a purely practical industrial perspective, I think, having lots of data and being able to train with diverse data sets, being them collected and annotated somehow manually or being generated is very important. But I still think that in the long run, some ability to self-supervise and adapt should be essential in order to be robust, right? I mean, especially to get kind of, this long tail of events, the idea of actually being able to produce in-house all possible combinations before getting out there and actually dealing with the, complexity of the world seems a little bit unrealistic to me. I mean, still practically, we may be able to actually do very well with lots of data we generate for specific tasks, but I think that level of robustness we aspire to have would be probably also coming out of some sort of self-supervision process.
Great. I'll take the conversation a slightly different direction. A few of the questions that came up today were around more social and ethical challenges of VR. So these devices that, as we wear these, they'll know an awful lot about us. So privacy is something that a few people asked about. One example that came up was during Michael's talk, where we were reconstructing 3D environment of someone's home. Who owns that 3D reconstruction? Is that somehow the device owner, or is that the person wearing the glasses? I wonder if the panel could talk about the privacy challenges and concerns and thoughts that you have with these new devices.
Well, I have a question. I mean, is the person paying for the service, or are they not paying for the service? I mean, I have this, no offense, Michael, but my idea of the business model of Google and Facebook is it's kind of like the 2 chickens in the chicken yard, and one chicken is saying to the other, yeah, and all the food here is free. So if you're not paying for it, you're paying for it. And we should have an understanding that there is no such thing. There's no such thing as free when someone is providing you with any sort of a service. So if we start to think seriously about the bad implications of violated privacy, we should be prepared to think about how do we arrange things so that privacy is protected as a fundamental right. And that is a collective cultural decision. That's not a decision that we shouldn't be fostering off on Facebook or Google. We have to be accepting that as a society of citizens and taking responsibility for what do we want.
I love that, Ken, because basically in a democracy, the people and their institutions should make decisions about important matters such as that with open discussion. And this is something we have started talking about openly long before there will be an AR product. And I think that it's an interesting dialogue. I do think that privacy and security are critical to this, no question about it. And the system is being built so that whatever policy is needed can be put into place. But, as a society, I hope, someone asked me how long before we have good AR glasses. And I said 5 to 10 years. And that's plenty of time for us to have that discussion. And I think that's critical.
Yeah. So one other So the social challenge that came up was social acceptability. You know, will we ever get past sort of that barrier of people wearing these things, these glasses around, these VR headsets around? Does it appeal to the mass populace to wear these things? And
VR headsets or AR headsets?
either one. I'll let you.
I don't think people are going to be wearing VR headsets around out in public too often. But AR glasses, I mean, you know, I think about the fact that 15 years ago, if I was with someone and there was a noise and they took something out and stopped paying attention to me, I would have been mortally offended. Now it just happens all the time, right? And people can take pictures of everything now. And so I do see that societal norms do shift over time based on how useful something is. And what it really comes down to is how useful is it, right? If people want it, then those norms will shift, or the technology will, you know, address the concerns. And if not, then it won't happen.
In the talk of Ken, it was interesting. He showed this eye contact or contact lens. So, and in the chat, there were a few people commenting on contact lenses. Do you think that even glasses form factor is enough really for adoption, or do you think it needs to go further, like toward more eye contact type, like form factor for that to work?
About 5 years ago, every time I got up in front of a class or an audience, I actually started to pay attention, and I noticed that, at least in the circles I travel with, about 50% of people are wearing glasses. And here's the interesting part is if I didn't look, I wouldn't have been able to tell you which people are wearing glasses. And that to me is a sign of a successful socially invisible technology. So I don't think wearing glasses is the showstopper, because we already don't really think about whether someone's wearing glasses as far as how we assess them socially.
I also think that contacts are a much bigger barrier because a much smaller fraction of the population wears them or is willing to wear them. But the other thing is, if you put on glasses, you have a rigid observation platform that's capable of doing significant work. If you put in contacts and beam stuff to them, you are working within unbelievably tight envelopes at best. And you no longer have that rigid observation platform. And to me, it seems like it is a significantly less powerful situation. Just as an example, suppose that the glasses have the ability to warn you, totally off the wall example, that a car is headed towards you and you should get out of the way, right? Contacts can't do that, right? But the glasses can have pretty close to a 360-degree view around you, and they could have that information. They can just tell so much more about your context, both because of the power and thermals and because of the platform. So even forgetting AR itself, just in terms of what these can do for you, I think glasses are really the right package.
Yeah, Michael, that's really interesting. It seems like you're saying, you know, glasses somehow expand the, you know, give you superhuman powers effectively. And I found it interesting in Ken's talk. He used the word evolve, I think at least once. I'm curious, you know, there's some things that seem like are non-negotiable in terms of our experience of the environment, like 6DoF tracking of the headset. But there's other things that we are able to evolve. Like maybe our representation, things like that, that are more negotiable. I'm curious where you see us potentially evolving to accommodate this new technology.
I don't think we evolve to accommodate new technologies. I think we adopt and fit technologies to what we already are. There are a whole bunch of things about the biological evolved human that have been pretty stable for at least 100,000 years. You know, our ability to not just to use language and to learn new languages, but also our ability to meet strangers from other tribes and figure out whether we can trust them. The other great apes can't do that. There's been a lot of research and that we're quite unique among the primates in our ability to navigate interaction with strangers. You couldn't have a biologist friend of mine pointed out that you couldn't have a Starbucks for chimpanzees because a strange chimpanzee walk in, they would all kill him. And so everything we do is about adopting technologies, whatever they are, whether they're books or they're sign language or they're anything, adopting technologies that work with the way our brains are able to, together with language, hack other brains and figure out, is this my friend? Is this a kinship group? Is this what kind of kinship group this is? So I don't think we should be thinking in a technocentric way, because it's very impoverished compared with thinking in terms of what is the essential human and how do we feed it.
And Ken, your key phrase there was building the models. Everything is about transmitting a model. If body language is about that, you know, everything about it is really context that you continue to build that model. And the thing about VR and AR is that they drive our perceptions at a level that has never been driven, that gives us modeling of a whole bunch of types of things we're evolved to do. So there's evolution, but we were evolved to do it, you know, as Ken said, 100,000 years ago. But it drives things into those models with a richness and a depth in a way that's never happened before. And I do think that that's critical.
Yeah, sorry. Yeah, great discussion. So yeah, we're at a computer vision conference, but I think Michael set up FRL explicitly to be a sort of multidisciplinary lab, because the problems here are so multidisciplinary. I'm curious, is computer vision sort of the right lens to put on AR, VR? Should computer vision community like be bringing in more multimodal type research?
The first thing I would say there is that if you were to take computer vision out, you've got nothing here, right? No aspect of it really has any value. So right there it matters. The other thing that's interesting is how the challenges are effectively open-ended, right? I mean, we've talked about live maps. Live maps is really, you know, in the long run, an effort to map all the things that matter to people, right? To have an index of the world in a location platform. And I mean, that's not an original idea, but it's something that would become possible with widespread AR glasses, which is an interesting thought. So if you think about it, displays are very hard and absolutely necessary because we're visual creatures. Audio, similarly, very important. Graphics, you can kind of run down the list of all these things, but in the end you say, what's the payload? And the payload is that understanding of your context, the ability to share it with other people, right? To be with other people, to have an assistant that understands what matters to you. Every one of those is a computer vision problem. So when I look at what the richest problem, like let's say we get a great display that weighs, you know, 5 grams tomorrow, works brightness, indoor, outdoor, runs all day. You know what? We're kind of done, right? If it gives you depth of focus. You can list the things and you can say, once you have solved these, you are done with this problem. But you can't say that about computer vision for this. I mean, you know, first the problem is, how do you even locate yourself? How do you stay stable? How do you locate yourself? How do you start doing mapping? But then how do you start segmenting, semantics, sharing with other people, and building on top of that up towards AI capabilities? So it is the open-ended problem here. I like to say to PhD candidates that we're talking to when we're recruiting that if they choose to work in AR, VR today, the day they retire, they can still be working in AR, VR, and the challenges will be just as big. They'll just be way down the road. And, you know, having been working with personal computers since before the IBM PC showed up, you know, I remember when my big challenge was, how do I get a texture mapping loop to run fast enough, right? And that we're talking about literally like 12 instructions. And think of how far that is from the problems we deal with today. But it's been a gradient, and you just kind of walk up that gradient, up all those S-curves, and they just keep going.
Yeah, Ken, go ahead.
Yeah, so it's funny because we also have an FRL, or we have a future reality lab at NYU, which I think was there before Facebook Reality Lab, but that's okay. You guys can keep the acronym too. And we found that the only way we actually get things done, and this is very consistent with what Mike said, but I think he didn't explicitly mention it, is these are not just technological problems. In order to create experiences for people, we need to be highly multidisciplinary. We have artists and animators, we have actors, we have writers. We also have a lot of great PhDs that come out of computer scientists. So a lot of what it takes to model and to create experience, and I know that this is true in Carol's lab as well, because we collaborated for a bit, is it's not about just the technological problems. There are things that really, right now, only people can do. And we need to use the very nonlinear mapping of human talent to get to a place where this is a tool that's meaningful to someone with this expertise. We're not going to be able to do a pure simulation and reach the use cases that we need to reach. And this is true of how we use ML, how we use vision, how we use graphics, how we use anything. We cannot be seeing it as a purely technological problem. We need to be multidisciplinary and use things we cannot yet model in the brains of experts.
And one thing I think so interesting in that line is that when you look at the personal computer and you think about how Licklider really viewed the personal computer as a way to enhance human creativity, right? I just feel like we're building a platform so a million other people who are far more creative can then do things with it.
So do you think currently high quality content is kind of key for many VR experiences, and capturing or generating 3D content is actually fairly non-trivial, as you showed? You know, we need to build also vision algorithm for that, or have people that are very skilled to be able to generate 3D assets. Do you think like creating this 3D content actually slows down the adoption of VR, meaning that like we have Photoshop for 2D content, it's much more understood by people, how to create 2D content and record videos, but 3D is much less understood. And do you think this is a kind of something that need to be also adopted by the consumers in order to, as a complement of the VR headsets, like, or to capture actually 3D data?
Well, I'd like to hear what other people have to think, but I know that when I first started working computer graphics and I started developing procedural textures, and it took an hour or two a frame to render something, so it was used in the film industry. And then, you know, Moore's law continues, and then it went down to a 30th of a frame or 60th of a frame, and suddenly it was used in the game industry. I didn't change the algorithms. They're exactly the same algorithms. You know, you could take the lines of code and move them, but suddenly it was relevant to a new group. So I find it extremely important that people like Jean Favreau and other people in the cinematic industry are starting to use these in-world creation tools because they're the ones who can spend the most computationally and buy really expensive equipment. And that means that they are the canaries in the coal mine in a good way. When the film industry starts using it, it means that things that are meant for direct consumer experiences are going to follow along a little later on the tail of Moore's law. So I think we already have our evidence that artists are adopting, let's create in world, but now the economics need to shift for it to get to other industries. And of course they will.
Right, I guess the point is though that still the content creation for the movie industry and for the sort of, you know, big games is still a very complicated and expensive process, right? So it's still in some sense far from being commoditized. And sometimes we look at those worlds and we say, well, if we only had those assets in a format that would be actually more controllable and more general, we may be able to use them to generate lots of interesting synthetic data. But then again, there's so much sort of work going into sort of very specialized cases. It's not very diverse. It's very hard to kind of.
This is a quality of, these are tools that are enterprise tools for people who have very large budgets and can spend months learning on training the tools. So there are two dimensions here. One dimension is when you have enterprise tools that are concentrated for productions that can spend $50 million to get to hundreds of millions of people, there's a certain quality about those. But we've seen in other industries, for example, cinema, just cameras themselves started out being very specialized tools, and even to load a camera at the beginning of the dawn of cinema was a very specialized thing. And then they became, we didn't stop having those, but then we started having the consumer versions of those. And you've seen this with photography, you've seen this with printing, you see this with When I first started, in order to actually make something that looked nice for an advertising, you needed a $100,000 Harry box, and somebody needed to spend a year training on it. And now you just have software that you use on your Mac, and it looks really great, and you send out your wedding announcement. So I think it's very important not to put this all in the same bin as enterprise tools for people with large budgets, with large payoffs, versus the commoditized version of those tools. What I'm talking about is taking that model and applying it specifically to creation in 3D, in world, in VR. That is going to be commoditized, like all of these other things have over time developed commoditized versions. But there will still always be the high end for things like making a movie.
I mean, I think one of the problems, I mean, there's so much data out there, like some motion data, 3D models, etc. But very often in the movie industry, for example, these resources are using different formats. They tend to be used in different kind of pipelines. Rigging is different, etc. And I think they tend to throw away everything into some dusty digital archive and start afresh and new with the next project or whatever. So I think, you know, in order for the content to be usable, there needs to be an awful lot more standardization and attention to reuse.
So I think we are running out of time now. Thank you. That was very interesting discussions, and thank you for all of you for the amazing talks.